Hey everyone, I'm Dennis Calvert, CEO at BioLargo. We're a proud sponsor of Blue Tech Week. This session is going to be about conservation and recycling of water, and it's my pleasure to introduce Mary Conley Eggert. Mary Eggert, I've had the pleasure of knowing her for a number of years, part of her association. She has an incredible story. Mary is one of the high impact people in the water industry globally. Uh, has organized a cluster that is organizing technologists together. And her background really started as a young girl at 12 with a passion for making a high impact in the water industry. And fast forward a few years, uh, she's now organized clusters. She's bringing technologists together. She's a thought leader. She's often a speaker of note, and she's gonna moderate this session with some astounding specialists in the water field. And Mary, we're so glad to have you here, and thank you for your leadership in the industry.
Well, yeah, well, Dennis, thrilled to be here with a truly exceptional panel that covers all aspects of conserving our energy and our water and protecting our water resources as well. As I know, many of you in the audience are focused on the oceans and streams that we don't want to be polluting with toxins, and this panel addresses that. Uh, topic is conservation. And what's interesting is, for thousands of years, people have talked about better managing water. It's only in the last 15 to 20 years that we've had the data, the robotics, the technologies, analytics to really address what we have available and also the quality of that water. And our panel today is going to illuminate for you the different ways in which we can watch over our water and also protect it. And I'm thrilled to have three speakers today, each of them covering a different part of our water sector, and some of them working together. And each one of them is going to share in 8 to 10 minutes sort of what their role is in the water sector. And then we're going to have a Q&A. So we invite your questions on how you can better steward water through these gentlemen and their organizations, and also your ideas in the chat. So I want to first tee up Jonathan Grant, who's been an active innovator out of Toronto. He's helped head up some of the cluster initiatives and innovation hubs, and he's also been behind some of the great technologies and enabled them to be commercialized. It's no surprise he's the commercial leader for Sentry, a new player, relatively new, and who is making waves already because of his work. And John will tell us more about that in about 8 to 10 minutes here. And I'm going to turn it over to you. As you notice, he never misses a moment to make an impact as he's on his treadmill there, making a difference with his body as well as with our water. Thanks, John.
Well, I'll stop walking, and I don't know how much of an impact I'm actually making on my body because I've gained weight during this during COVID. But I will say I love the analogy of making waves, especially at this conference. So thanks for bringing me in, Mary. Um, so I'll talk a little bit about what Sentry does and how that applies to conservation and recycling, and looking forward to some of your questions. So, first and foremost, we care about the environment and making better decisions when treating water and wastewater. Next slide. And that's not always possible right now because of existing tools for monitoring water quality. Real-time sensors need frequent cleaning, or they end up covered in crap, literally. And that's because biofilm grows on them and makes it hard to read sensors unless they're cleaned at least once a week. And who likes grab samples? That guy down in the right hand corner. They're great, to understand what was in the wastewater stream, 5 days from now, and provide zero information that is actionable. And so wastewater conditions are changing all the time, and most sensors can't tell us that because of biofouling. And what we've done is taken biofouling, and let it do the work for us. So next slide. So at its heart, what we're doing is we're monitoring, the biofilm reaction to, the wastewater conditions. So have you wondered what would happen, if you could actually build a sensor that was built to be in nasty wastewater conditions? We did, and essentially what we're showing here is two flat metal sheets that we prime with a small voltage to receive respired electrons, which allows us to essentially monitor the biofilm's response to changing wastewater conditions. And so what does that mean? It really means, next slide. It means as organic material passes over the sensor, the biofilm consumes carbon. As it consumes carbon, it respires electrons, and we just really count that rate at which the carbon is consumed. So in other words, we're measuring the ability of the biology in the process to treat the incoming wastewater. Or for laymen like me, it's very much a heart rate monitor for your plant's ability to treat that incoming wastewater. So if the line goes up, it means there's a large organic load coming in. And if the line goes down, there's less carbon available, due to either, toxic inhibitors or heavy rain events. And so that applies to conservation because, we have to spend a lot of energy to treat wastewater. So if we're treating it in an optimal way, we're much more capable of treating it if we understand actually what's coming into our plant rather than monitoring it, either with a grab sample or after it's passed through most of our treatment works, or it allows us to understand how to generate more electricity through co-digestion or anaerobic digesters. Next slide. So we do most of our work at the front of a treatment plant because we're able to go where other probes can't. So a primary clarifier headworks location so that we're able to monitor what's coming into the plant so that it can be treated appropriately, so that it can be discharged safely or put into a reuse process. And so the other two places where we go, and Corey will touch more on collection systems, next slide. We can go into the collection system to monitor the toxicity of industrial dischargers. And, it's kind of amazing what you'll find when new craft breweries show up in town and what they actually dump down pipes. And next slide. Or more commonly, we're used to optimize various processes. So aeration optimization, where we're able to, see 20% savings in terms of energy use and treating water more appropriately, so for environmental regulations before it's discharged, or co-digestion, which is very popular in California, where you're adding organics to an anaerobic digester to maximize biogas and renewable energy. Next slide. And so one of the things we say is, what you need is robust and reliable information that's low maintenance. And so it's one thing to say low maintenance. It's another thing to be low maintenance. So what you're seeing here are two probes duct taped together, really scientifically done, at a primary clarifier at United Utilities in the UK, their Skelmersdale site. And so one was installed in May of 2019, and the other was installed in October of 2020. And they were untouched for one 18 months, and the other, and then the other for 6 months. And as you can see, we took a week's worth of data, screen grabbed, and overlaid the two signals. They're very reliable and move in lockstep. And so we don't recommend that people do that. But in terms of if you want a reliable water quality signal to allow you to conserve energy or produce more, this one will provide that. Next slide. So it's really about detecting organic shocks. It's feed forward in a place where other probes can't. That's why we're so excited about it. And then really what we're saying is we can help identify quality issues that will affect reuse process or the outcomes from your plant. Let's talk quickly about a case study. If we go next slide. And so we're going to talk about Frankfort, Kentucky, which we love that. It's if you're a bourbon fan, it's where Buffalo Trace is. And sorry, next slide. And so the Buffalo Trace distillery is 150 yards upstream from the treatment plant in Frankfort that was built for a town of 30,000 people. And they basically have one of the world's largest distilleries discharging right next door. And so they had huge variable organic loads. They have huge issues when it rains a lot. And so what we were able to find through working with them were that there were unknown spikes related to the distillery that were causing the plant and then the river where they discharge into issues. And so consistently on Wednesdays they were getting landfill leachate trucks dumping into one of their lift stations, and they were also pumping biocide out of their EQ tank. So we were able to help them flag clear issues along with the the more random distillery discharges. Next slide. And so in short, what that meant was, they were better able to manage oxidation ditch loading, and we were able to understand the impacts of rain on their ability to treat. And they had a 10%, 5 to 10% improvement on their aeration. So that relates to, both dollars saved, energy conserved, and better outcomes for their discharge water. And now are part of their standard operations. They even got another system to monitor the leachate receiving body, or the leachate receiving station. Next slide. So we are a relatively early company, as Mary mentioned. We commercialized about 4 years ago. We've now got 115 or 120 deployments globally, about half municipal, half industrial. And almost all of them are on the problem statement of, I've got toxic loads or variable loads coming into my plant. I don't know how to identify them, and I don't know how to treat based on identifying them. And then we work with you to do that. For those local in California, if you know the D&H folks, that's who we've partnered with down there. And then, next slide. Our goal is really to help clients, with real-time information to help really processes, which, in turn will conserve, energy, help with the ultimate reuse, and really, reduce sampling or, high maintenance sensors so that we can really have better outcomes. And so next slide, thank you very much. It's looking forward to the questions. For us, it's all about quality. But one of the questions for, when you are using water recycling, you have to know how much shit is coming down the pipe. So over to you, Mary and Corey.
Yeah. Wow. Well, what a great overview. And I just want to point out to the audience, if you notice the different connections, the clusters that John's working with, PUB in Singapore, San Francisco Public Utilities Corporation, these are leading initiatives, sort of people on the forefront who are good at testing and validating solutions. So I just commend you for that, John, and making sure it's in the hands of the right people who can prove out the value that you deliver. And Corey was actually raving about John beforehand, and Corey's raves mean a lot because he's been in the water sector for 30 years. He's helped also launch some very significant companies. One of my favorites, Optimatics, who was acquired by Suez, and helps people save everything, energy, water, and eliminate leaks or identify leaks. But he most recently authored an article or a guidebook on cybersecurity, and he has practical guides for utility executives. He's just an amazing resource who wants to help the industry, and you're all privileged to know him and John, and soon meet Umang, as resources to add to your network. And Corey, SmartCover has a tremendous history and working alongside utilities. I'm wondering if you could tell us about that and sort of what got you excited to join the company and the impact that you're having today.
Yeah, you bet, Mary. Thank you for the very, very kind words. Can you hear me okay? Very good. So, and thanks for those. And Mary, just to quickly clarify, I was not raving about John. I was raving about Century. So we should make that clear. So no, John's one of my favorite people in the industry. So no problems raving about him. But kind of speaking to John's theme about knowing what's coming down that pipe. That's That's where SmartCover really comes in. So just a quick overview of the company. So we're an intelligent manhole and analytics company. We are putting sensors and instrumentation underneath the manhole. We actually have a patent to connect to the underside of the manhole. And we're doing traditionally level sensing and now hydrogen sulfide sensing. What we're using that for, and the real reason the company was founded, we were founded by a couple of water industry folks, guys that were sitting on water boards, and they see this problem of overflows, and they say, well, surely we can solve that. And ironically, they were rocket scientists, like literally rocket scientists. And they said, well, we could put that brain power to solving the problem here of overflows. And that really is what they set out to do. And so they created SmartCover to identify for utilities when an overflow is about to occur in their system, sanitary sewer overflows. So what we do is we provide alerts and alarms that let the utility have enough warning to get out to that location with the appropriate equipment and prevent the overflow from occurring. Now, what's happened subsequent to that is that we've learned that, well, hey, most of those overflows are caused by some type of a buildup or blockage in the system. And now we can use SmartCover to say, when is the optimum time to go clean that particular line segment? And you think, well, what do they do otherwise? Well, what utilities do otherwise is simply schedule a routine cleaning. And, kind of under our theme of conservation, it's roughly 10,000 gallons of potable water that are used to clean a line segment every year. And most of that is unnecessary. What you find out from our customers, and we have over 500 in North America, that we can eliminate 75 to 90% of routine cleanings and instead do it as an on-demand. We can provide alerts weeks in advance that can be scheduled into the maintenance system for crews to go out and clean a sewer because there's an upstream blockage, a downstream blockage, a grit buildup, a fat, oil, and grease, or as we all know now today, flushable wipes that aren't flushable. That have been flushed for the last 18 months. And that's created, obviously, a lot of blockages in sewer systems. The other big thing that we're doing, again, from a conservation standpoint, is we do a lot of I&I impact. So you use the SmartCovers to determine where is the inflow and infiltration coming into those sewer systems during rainfall events, and correlating the rainfall to the impact of the I&I. Just because you have a large volume doesn't mean it has a large impact. And what we're looking at is the impact of the I&I in overwhelming the treatment plant or causing massive energy spikes because you have to pump and you got to do all kinds of stuff. So eliminating and minimizing that I&I and directing where it needs to go, not just on the main, but on the laterals to the sewer connection. So those are that's kind of the highlight of the company. It's why our founders really got into the business. It really started with the overflows, and then learning from the overflows that cleaning is a big preventative. And when do you clean? And it gets onto all the stuff that we're dealing with today after COVID, right? Like labor. And we don't have enough folks to go out and clean. So how can we clean everything? We need to know where to clean. So it's those kinds of things.
I think those kinds of things are really meaningful for investments by utilities. But I think the investment that a lot of people who are at this Blue Tech Week care about is how do we preserve our oceans and our waterways? Mm-hmm. Maybe you could talk briefly about your work with Oceanside or Lake Worth Drainage District, where you all are sort of preventing those spills from going into the ocean clean. That would be great.
Water finds a pathway, right? So when that water comes out of that sewer, it's going to go somewhere. And it's going to typically flow into a storm drain or into the nearby creek or into the ocean or whatever the most adjacent body of water is. That's where it's going to go. Water will find a path. We know that. And so when you're preventing these overflows, and we're talking about, anything from 10 to hundreds to thousands of gallons, hundreds of thousands of gallons potentially of overflow, typically, not that large, but you're talking about all of that. And it's yes, it's diluted from the rain, but it's sewage. And we certainly don't want that flowing into the oceans. Now we're closing beaches and we're shutting down the river stream, and we've got to go clean it. And the expense of cleaning that, whether it's your local pond or it's the ocean, right? And trying to figure out not only the cleaning, but just the public's trust in our utilities, right? I tend to think of things in the utility context is, number one is sort of elimination of risk, right? We want to eliminate risk. Overflows present a risk. It presents a risk to the public health, to the environment. There's also then the second piece, which is the reputational impact. Who thinks about their local wastewater utility? No one should raise your hand, right? In the audience, no one should think about it, right? It should be silent, dude. No one should wonder about their local wastewater utility. Why? Because there's no problems. Reputational impact is a huge deal. If you're having overflows, if we're having issues, if sewers are collapsing, if we're getting raw sewage into open waterways, including the ocean, now I've got a reputational impact. So I tend to think of it in that context, and a lot less about the physical ROI. There's ROI with what John does, with what we do, Lumeng does. There's ROI, but it's not as important as the risk reduction, the reputational impact, and then the ROI.
Right, and I recall Twist, who founded your firm, actually started working on Cryptosporidium with a desire to collect or prevent all of those health issues. So that ROI, saving citizens, saving economies that go dead if pollutants pour out, is huge. Wonderful conservation efforts. So, Corey, one last question. You joined SmartCover after being with many successful firms you could have stayed with. What attracted you to it, and what do you want to accomplish?
I love the mission of this company, right? It's tremendous. I loved all the companies I've worked for. Optimatics was tremendous. Suez is great. I loved my time there. But the opportunity to work again in a startup context, and SmartCover's been around for 15 years, where I wouldn't call us a startup in the traditional sense, but it's a growth company. And to be at that forefront of being able to have these solutions that are so affordable, that solve such massive problems, right?
Right.
There's over 100,000 overflows in the United States alone every year. There's over 100,000. We think of ourselves as so developed and so, we're above all of that. No, we're not, right? There's over 100,000 overflows every year. In the United States, there are still nearly 2 million illnesses a year from sewer. Right now, how do we have that? So when you look at a SmartCover and you think, how can we solve these problems? Not by just throwing billions in infrastructure funding at it, but how can we solve it at a local level, really economically? And that's one of the things that just attracted me to SmartCover. Greg and David Drake, who founded the company, never talk about cost or anything else. They talk about 100% about we're here to protect the environment and the public health. That's what we're here for. And it attracted me, especially to be able to do that in an affordable way. You think about all this environmental justice and social justice and underserved communities. You can put a SmartCover in place, and I can guarantee you it's not going to overflow from that point on.
Yeah, and that's also what we had the pleasure of interviewing about 100 of your clients who actually said that, and they gave you ratings like Apple gets. 94% would refer, 93% were totally satisfied and excited, but also the elimination of overflows, because we get smart, is so important. And that's what each of you is doing in your own way. And I'm thrilled to have Uman Yagnik here, even more thrilled because he survived a huge flood in British Columbia, and he's actually in a suit, not in a hoodie. So he understands what it means to be dealing with real world water challenges, folks. But he is a trooper. He rode 6 hours last night to get out of his flood zone back here to be with us, and has a tremendous technology, the hollow fiber membrane, which has a unique capability to efficiently clean and treat. And I'm going to let him tell you more about that. And Uman, delighted to have you here. And tell us more about NX Filtration.
Sure. Yeah, it's good to be here in my home office finally after the ordeal. But it's fantastic to be with you and John. It's just an opportunity I was always looking forward to be a part of. to quickly talk about NX Filtration, I'm the commercial manager for NX Filtration representing North America. The technology is centered around direct nanofiltration, hollow fiber membranes to help you reduce not only the carbon and the chemical footprint reduction, but also for the water footprint reduction for industrial end users. If you can go to the next slide. So this is kind of the macro level, and that's what I'm going to do through the course of the next 8 to 10 minutes is kind of take you from the macro to the micro level. And it's important that we understand the global issues in and around water. So 2 in 7 people globally do not have daily access to clean drinkable water, and 2/3 of the world's population will have be living in the water stressed areas by 2025. Surprisingly, only 2% of treated wastewater in the European Union is reused, which was quite a startling fact. But 80% of the world's wastewater flows back into nature without being treated, and that's what is the center of this particular conference of water conservation recycling. 95% of medicine waste, pharmaceuticals and drugs, these days there are talks around micropollutants, PFAS. They end up in our sewage systems. And so the United Nations kind of built this sustainable development goals, and NX Filtration's environmental sustenance and governance agenda is kind of around those 5 UN SDG, with the focus on SDG 6, which is the clean water and sanitation. If you can go to the next slide, please. And this is just not at the United Nations level, but several governments, regulatory authorities, municipal industrial partners are also talking about how to reduce the water footprint and how can we help them achieve that by reduction of overall carbon footprint and chemical footprint. So we have the UN SDG 6 that we are focused on, but the U.S. government is now talking about the infrastructure bill which got passed. The World Economic Forum is kind of gathering about 900 partners to facilitate over $890 million worth of water-related programs. Industrial partners like Pepsi, Amazon, they're talking about water reuse. Municipal water treatment companies like Veolia, Aqualia, they are talking about reducing the water stress. So how do we really help them achieve these or address these concerns? If you can go to the next slide, please. So what we do is we are an advanced hollow fiber membrane company. We provide or manufacture breakthrough direct nanofiltration membranes that are really designed to remove not only the suspended solids, turbidity, microorganisms, which include bacteria, virus, but also micropollutants, pharmaceuticals, nanoplastics, color, organics, everything in one step. And this is quite an innovation in the industry today. Our products are patented through years of research. I mean, if you really combine just the top 5 or 6 people in our R&D team, we have over combined 125 years of membrane experience. So what our value proposition really is we want to help you not only reuse wastewater, industrial municipal wastewater, but we also want to do it efficiently and sustainably. So by reducing your overall CapEx and OpEx, and also help you reduce your overall, draw off raw water or groundwater, surface water. Next slide, please. So the heart of the technology is into the membrane itself. So these are really, if you think of these as straws or spaghetti noodles that are hollow, and the technology of manufacturing these membranes is what is at the heart of NX Filtration. We have a layer by layer nanochemistry that goes into manufacturing of these hollow fiber membranes, where the feed flow kind of flows from inside out of the hollow fibers, and that's where the removal happens. And you'll have one water stream that is concentrated in the pollutants, and the other stream that is filtered out, just clean, and we call it a permeate water. Most of our systems operate in the range of 75 to 95% recovery, and they get installed as modules. The last picture on the left that you see is an actual installation where we have had our modules installed in a site in Hungary. Next slide, please. Conventionally, if folks who are familiar with membrane-based treatment processes in the industry, when we talk about secondary or tertiary wastewater treatment for water reuse, we've always seen several steps in the treatment process. I mean, you will have some sort of conventional treatment where we're talking about primary clarifiers, secondary clarifiers, anaerobic digestion, and then you were talking about some sort of coarse filtration, followed up with ultrafiltration, and then reverse osmosis. I mean, this is a really long treatment process. What it ends up doing is it leads to not only just extensive pre-treatment, leading to a much higher capital cost, but also very high operating costs, because you have to use a lot of cleaning chemicals. There's a lot of energy used, because these are high pressure systems, especially when you talk about reverse osmosis at the end. We want to really shorten the overall process. If you can go to the next slide, please. So the value proposition, when you compare this in terms of the total cost of ownership, we've compared our direct nanofiltration hollow fiber membranes from NX with a traditional hollow fiber UF, either follow it up with a nano or a traditional ultrafiltration, follow it up with an RO. And there's a clear savings, not only just in the total cost of ownership, but what's quite remarkable is if you see that energy bar in that graph, it's about 1/3 of you would typically see from a UF-RO or a UF-NF kind of a process. And what's also important is the absence of pre-treatment chemicals. So we don't need any coagulants, we don't use any flocculants in order to precipitate those organics and pollutants to get rid of those membrane processes. So your pre-treatment chemical consumption reduces, and overall cleaning chemicals consumption is also way less compared to traditional membrane processes. So it's a one-step treatment process with reduction of carbon footprint, chemical footprint, eventually enabling you for reduction in water footprint. If you can go to the next slide, please. So, I mean, these really summarizes what the product features are and how they translate into benefits and commercial advantages. The membrane itself is chlorine tolerant, which means that when it is geared towards treating and removing organics, it can be cleaned with chlorine. And all we really need is stock chemicals. We don't use polymeric cleaners, which would eventually go out in the drain. And hence that's how we're also providing a pretty sustainable cleaning operation. And the cleaning frequency is much less. We're talking about chemical cleans once every 3 days to once every 7 days, versus traditional membrane processes which get cleaned once a day or twice a day. We have a pretty robust membrane in place, which would mean that your replacement of modules would happen less frequently, because most of the companies really don't have an answer to where these modules or membranes which are once used will get dumped into. So that's another way of addressing the sustainable problem. If you can go to the next slide, please. So we have substantiated it. Now, this is all NX Filtration talking. Now, we went out to institutions, both academic and industrial, and we asked them to kind of verify this. Some of those white bars you might not be able to see, but let me take you through. Starting on the left top corner, we saw how can we better reject micropollutants compared to conventional spiral wound nanofiltration membrane or spiral wound reverse osmosis membrane. So PFOA, which is one of the PFAS compounds, we saw that we are getting 95 to 100% removal. In terms of the proof of cost, the operating cost for a fully operational system of direct nanofiltration only would be in the range of about just the power consumption would be in the range of about 96 cents to $1.36 per 1,000 gallons of treated water. And this testing was done both in Europe and has been validated by customers in North America as well. We have over a dozen and a half installations globally now, ranging from as small as 11 gallons per minute to as large as 800 gallons per minute. So it's been validated by academic institutions, it has been validated by industrial partners, and has already been tested inside. So it's not something that we say can be done. It has been done successfully for the last 3 years. You can go to the next slide, please. This is kind of a broader snapshot, and below you would see some of the bigger partners that we have worked with, Veolia, Qualia, PWN, PepsiCo, and Pernem in Southeast Asia. We have worked on several applications, ranging from helping an aerospace company reuse their wastewater so that they can reduce the raw water intake. We have helped a textile company reduce their raw water intake and reuse a lot of their wastewater. We have helped food and beverage companies, treat their water efficiently and reuse a part of the water back in their process, and not to send it down the drain. So we have worked on a slew of different applications, and really the possibilities are limitless. If you're going to go to the next slide, please. So this is kind of the history of NX filtration. It's quite interesting. Professor Eric Rusink, who's the CTO and founder of NX filtration, has been in the membrane industry for pretty much, forever. 1980s was when he really started becoming active in the membrane industry after his PhD at the University of Twente in the Netherlands. And since then, he has been pretty active. In 2013, he got together with his team, his PhD students, and started NX filtration. He was also instrumental in founding XFlow, which then eventually got acquired by Pentair. But Dr. Rusink's vision and really the objective with which NX filtration was founded is, Netherlands relies on groundwater for drinking water, and on occasions when they would have drought, they would have to rely on surface water for drinking water, and there were excessive amount of pharmaceuticals in the surface water if they had to be straight use for direct potable use, and that's when this technology would come into play. We help you remove pharmaceuticals, micropollutants, and really one-step treatment to help you get drinking water. And with that vision, we founded NX Filtration in 2016. We started our forced production facility, and piloting is a big part of our business model, where we would send out pilots to sites and help you see it and to believe it. We've had a couple of acquisitions on the way. One of the major ones being we acquired Hydronautics' HydroCap product line, which is a PES into-out, ultrafiltration product. We started our second production facility in early 2021. But one of the most exciting news along the way for a young hyper-growth company like NX Filtration is we got listed on Amsterdam Stock Exchange. So we went into an IPO in June 2021. The company got valued at 550 million euros, 30% of which was floated in an IPO. So it's not just the water community that understands what we have to offer in terms of innovation in this technology, but it's also the financial community that's backing us up. They believe in what we have to offer, and the overall, broad picture of the sustainable, technology of reducing carbon footprint, chemical footprint, and help you reduce your water footprint. Next slide, please. Kind of a quick snapshot of what we do. As I mentioned, we are an advanced hollow fiber membrane company, although our core product line, or let's say all our focus is on the direct nanofiltration membranes, because that's where the entire value proposition is. But we also offer ultrafiltration, microfiltration products that find applications in just pretreatment to existing membrane processes, for colloidal silica removal. When it comes to, power plants, we also help you with beer clarification, wine filtration, so some of those fancy applications as well with our microfiltration products. So that's kind of the basket of offerings. Next slide, please. As I mentioned, pilots form the backbone of our company and the business model. Unlike a lot of membrane companies out there who would offer membranes or membrane modules to system integrators to build a pilot, and then, that's their share of investment. And we actually own our own pilot fleet. So, starting from as small as a 1/4 gallon per hour to something as large as 13 gallons per minute, which is a full-scale, fully automated, remote monitored, remote controlled pilot unit. We have a slew of pilot fleet across the board. Right now, if I have to say, and I don't want to be wrong at this, we have about 15 full-scale pilot units operating across the board. We have one full-scale pilot unit operating as we speak in the city of Melbourne in Florida. I have about half a dozen bench scale units available in North America, 2 of which are in active deployment at the moment. Go to the next slide, please. So that's the overall message. I mean, sustainability is at the heart of NX Filtration and what we do, and this is not just in terms of application and what we help achieve the customers or the end users. This is also imbibed in what we do as manufacturing. Unlike for those who know hollow fiber membranes or aware of hollow fiber membrane production, there are active solvents being used in the production process. The entire chemistry that we have built around the hollow fiber nanofiltration products is green chemistry. So it's all aqueous based. We don't use any solvents. So it's not just the end use or the end application, but even with our own manufacturing process, it's all green chemistry. We don't use chemicals. We are energy efficient when it comes to not just manufacturing, but also when it comes to helping customers use our product and in their systems, helping them avoid pre-treatment chemicals and reduce chemical consumption. All that kind of combines to this overall message of reduction of carbon and chemical footprint. And I think that should be it. If I go to the next slide. Next slide. Perfect. So I guess that's the message I wanted to give over to you, Mary.
Yeah, well, I can see, hopefully the whole audience can see also why we have aqua optimism in this group. I mean, there's inspiration, innovation, and access for everyone. But I think most importantly, like when I entered the water sector about 6 years ago, I realized that there's like a 20 to 30 year adoption cycle for innovations, and you guys have really cut it down. I'm wondering if you could each just share, like, what would it take? And there are lots of people in the audience who might be able to spot places where you could be applied. If you could just talk about like a certain scenario where you would be a great fit and how long it would take for someone to say, hey, there's a problem and you've resolved the solution. And if we could just go John, Corey to Umang.
Sure thing. So for us, it's really anything coming into your wastewater plant where you're experiencing biological imbalance, toxic shocks, and that's leading to effluent issues. So if you can identify that, that's our sort of bread and butter problem statement. And then in terms of how long we can solve it, pretty quickly. I mean, it takes us a couple of weeks to get it out to you, and then because of the nature of our sensor, it takes a few weeks to, identify the right procedures based on, high and low signals at that particular spot, and then, off and running. And
so 6 weeks, you could be having that addressed with automated insights served up?
Yeah, it's so we have a dedicated technical resource on our team that works with clients to identify what should trigger alarms and then what action should be taken, and we usually do 6-month, year-long initial deployments with clients. So
yeah,
in about 6 weeks you have
awesome.
a good idea if it's working, though.
Excellent. And it's in. That's super. Corey.
Yep. Yeah, so the term we use actually internally is instant infrastructure, because SmartCover because we use satellite technology. We don't have any dead zones. We don't have any of that kind of stuff. Our installations are anywhere from 45 minutes to an hour. So who needs them? If you have an overflow, you should be getting a SmartCover. So it's pretty universal. If you're doing cleaning, you can use SmartCovers to reduce that cleaning frequency. So it's a pretty universal thing in terms of wastewater utilities. And if you have overflows in your community, it's an easy and quick way and an inexpensive way to stop those. 45 minutes to an hour for installation for us, and we can do it anywhere in the world. We have a number of anecdotal examples. My favorite one, I'll take just a second here. We were in Texas, and one of our folks installed the units, and they did a number of them that day. Heads off to the hotel after the last one and gets a phone call from the client. The client says, hey, we got to go back out there tomorrow morning. That last unit we installed, we must not have positioned it correctly because we're already getting an alarm. And our guy went, I'm pretty good at this. I don't think I installed it wrong. So I'm going to go check. He drives back out to the site. He flips the lid and he says, you better get a truck out here. Within 45 minutes of installing a SmartCover, it prevented a spill. So, and we have a number of examples in less than 2 hours, less than 3 hours, where spills were prevented because they took the 45 minutes to install a smart cover.
Yeah, that's amazing. And I know one of the mottos too is I love that instant infrastructure, but helping operators sleep well at night. They don't have to be told in the middle of the night that they have a problem with a spill already in the street, but they can save
That's
their
right.
reputation and their sleep by looking at the levels ahead of time. Yeah. And Umang, how long does it take to get a hollow membrane filtration system set up? And it sounded like you did it as a service potentially with these pilot things. Could you explain?
Kind of. It was on a rental agreement, or we would just give it out there for them to believe it. The technology works, but it's definitely longer than what John and Corey kind of suggested. I love the term instant infrastructure, Corey. I'm probably gonna borrow it in some of the future talks, but it's not going to be instant for us. The technology, especially membrane processes, they need a certain stabilization period, and not just for the membranes itself, but for the end user to be convinced that the technology is going to work through different patterns. And when it comes to membranes, it's chemistry. So there are a lot of variables. There's temperatures. There's different flow conditions. You have spring runoffs. You have varying turbidity, suspended solids. The inflows of pollutants could increase or decrease over seasons. So typically, if it's a large municipality, or if it's a large end user, they would want to pilot test this technology for the course of anywhere between 3 to 6 months, or even a year. We've seen pilot tests as long as 18 months as well. And once that happens, that's when they would want to design a full-scale system, and for which we enable them with process design. We have in-house projections tool, which will give them a good idea of what a full-scale system would look like in terms of hydraulics, what is the estimated permeate quality, etc. And after that, I guess the project coming into execution would be about another year or 2 years and a half, depending on the size of the project. But yes, it is a long project cycle for us, because the solution that we provide is really at the far end, and it's a nice flow in this panel. I see John and Corey talking about their solutions being used at the very front, right at where the discharge starts, and we come into play right at the very end. So when you want to talk to industrial end users who would rather discharge the wastewater in an inefficient way, with less treatment, we would come into play. If they want to reuse a lot of their water so that they can reduce the load on natural resources, that's where we come into play. If there are municipal end users where we want to reduce the impact on micropollutants getting dumped into natural water resources, that's where we come into play.
Yeah, and that's a nice way to look at the whole system. I know some people can look at a wastewater system and see waste, but the beautiful thing is you who work in the area know that waste becomes nutrients, energy, and water, and it's all useful resources. But it's been rapidly changing, the whole water sector. And I know we have some students in the audience. I'm wondering if each of you could sort of reflect on if you were a student right now, what advice would you give students who are considering a career in the water sector? And maybe you could share like your best move that positioned you well for today, if you can remember it. Just a little short story. We'll go
Mary,
same order.
I think that I'm gonna jump in front of John, because when you say if you can remember it, I think that was a direct shot at my age. So, listen, it's funny because a lot of this takes place by happy accident, right? You get a civil engineering degree, you get an environmental engineering degree, whatever, and you think, okay, I'll look at water, wastewater, I'm going to look at environmental, and I'm going to go design clarifiers, I'm going to go work on design, I'm going to go into an engineering firm, or I'm going to go to a public utility. And I don't know, my fellow panelists what their stories are, but mine was an accident. I mean, I got stuck in the computer group. That's what it was called in 1991. That's how old, right? And that was what it was, the computer group. And I was like embarrassed with my friends, because they're all sitting in cubicles at engineering firms doing design work, and I'm doing software and technology. Well, they're all still sitting in cubicles doing design work, and I'm having a ball. Right. And I guess if there was any one thing it would be is, it's not about the career move. It's like, when you're at something that might be at the forefront, like, don't be afraid of it. Don't be jealous of what people are doing in a traditional context, and they might even be succeeding in that traditional context. Don't be afraid to do something that's just completely out of the realm of what's going on at that time. And that's what it was. That's what digital was in 1991. I had a 286 on my desk, and I thought I was big stuff, right? So yeah. So sorry, John, for jumping in front, but I want to use my age and wisdom in that.
No worries. I have a follow-up question. What's a 286?
Yeah. Somebody mute him.
Yeah, no, it's. I mean, I sometimes joke that my life leading up to this point is a series of mistakes that somehow worked out well. So when I finished grad school, I was studying transboundary water politics and economics. So I was applying to jobs at the World Bank at their office in Addis Ababa, Ethiopia. And while I was finishing up my thesis, I got introduced to the right people at the right time. Dave at XPV. He introduced me to the first organization that I joined, and I just kept getting a lot of smart people to learn from. Corey's one of them. And that's just led me to getting to the right places. So don't be afraid to ask people questions. I think that's a key thing for students and young professionals. It's go out there, talk to people, meet as many people as you can, and learn from them. I will plug that we have a job posting for entry level, for 3 entry level people. Reach out to me if you have a resume, if you're graduating soon, if you're a student. So, always looking for smart people who are willing to come to these things. Yeah. Mm-hmm. I mean, not with me, with better people that I work with.
I don't know if I have as much wisdom to share as Corey and John, but I started my career with oil and gas. I used to work with a company that would build refinery petrochemical plants, and at some point when I was pursuing my marketing management, and I came across with a gentleman who was in the water industry for 30 years, and he asked me a question which was at that time was a jargon. You do want to work in a sustainable industry, and I was like, what do you even mean? And he said, well, at that time he meant sustainable for me, as my career, because that's going to be, water is going to be there forever. But what I now realize, it's not just sustainable for my career, but it's sustainable for the world at large. We got to talk about water issues at large. And what my career has helped me do is travel to places, not to explore cultures, but travel to places to understand the different kind of issues that people have. We're helping a municipality in Indonesia to treat straight river water, which otherwise is 1,000 color units, over 200 ppm TOC, straight converting into drinking water. The project being partially funded by the government of Indonesia and the World Bank. And these are some of the fascinating things that you could do and talk about when you are involved into the water industry, especially companies that are at the forefront of technology and innovation. And while Corey and John have touched upon what students should be doing at the start, I think I'll leave it at, once they have progressed and into the careers and in the industry, one thing to always remember is surround yourself with people that are smarter than you. I think that is a big driver for me, and that is one thing that I've enjoyed during my time at Hydronautics, at Man and Hummel, at NX Filtration, is that I've always been fortunate to be surrounded by people who are more smart than me.
Yeah. Well, and I'll take your cue talking about surrounding yourselves with people who are smarter than you or people who can solve problems you face. I'll give a shameless pitch for globalwaterworks.org. For all of you in the audience, it's an open collaboration platform that we created because when we entered the water space, we knew there were all of these problems like sewer spills and operators going out to test when it wasn't really healthy for them to be in the field like that. And we said there's got to be a better place or way for people to find solutions. So we put together Global Waterworks as a platform that you can all access, and you'll find these members in our Water Tech Showcase. I need to add Sentry and NX Filtration, but we'll also find about 2,000 water pros who care intimately and passionately about solving the global water crisis in this generation, and everyone has a part to play. And you'll find people in your tribe. You can search any topic. You can also add comments or resources that you find in the sector. And the whole goal is to shortcut the process by which we learn about the solutions that Corey and John and Umang have shared today. And before we close, I'd like you guys to share, that was my gap that I saw in the water sector. If we're going to solve the global water crisis in this generation, we need to cut through the silos. We need to bridge the groups, and we work closely with TMA Blue Tech and the Water Tower and Swan and other groups. What do each of you, what would be your wish list for Christmas if you were able, or for Hanukkah, or whatever celebration, Thanksgiving, that you would say, put that on my platter and we're done?
Well, I'll say despite
and you
being,
start
despite
living.
Oh, go ahead.
No, go ahead, John. You started. Go ahead. Go for it.
I was going to say, despite being in Canada, I am mostly American and will be celebrating Thanksgiving. So, yeah, I mean, my thing is when I started working in the water sector, a while back, the biggest thing were the silos. And what I love is that we're starting to see partnerships that create value, because we're not all going to solve everything on our own. And so by working with, people who have similar but not the same technology where you can collaborate, that's the way to win. And that's how we're going to solve it. We have the technology. We know what we need to do with certain types of water or wastewater. We just need to work together.
Hear, hear. Thanks. You do a good job of that too, John. You too, Corey. Speaking of that, you can tell about your partnership, Corey.
Yeah, no. So, I mean, we're trying, Sentry and SmartCover are working together to see if we can take our sort of platform, underneath the manhole, the communications, the power management, those kinds of things that we do, and connect that with the instrumentation that Sentry, that the awesome stuff that they've created, and see if we can get that out into the sewer system and out of the plant. So we're working together on that, and it's easy to work with people that you like, and easy to work with people that share a vision. So that's a plus. If I was to think about, I'm going to extend and steal maybe two things. Number one is we got to solve procurement in these public utilities. It's the biggest inhibitor we have to innovation adoption and solving real challenges, because you can't get 3 bids for something that's completely unique, and you can't go through traditional processes that take years to do to get innovation that can help you instantaneously. And one of the things that I think we as technology providers can do is we can stop using words like pilot, and we can stop using words like proof of concept. And I'm guilty of it, because I probably still say it every day. But when we think about trialing technology at a utility or at an organization, it's the trial is within their environment. It's not a test of the technology. It's not a test of the innovation. That's already been proven, right? Now, some might still be in a beta context, but particularly for the group that's on the call today, that there's nothing that's not already proven about the technology. And when we use words like pilot, we're telling all of the end user community, this is new and it's unproven. Well, no. It's proven. Let's test it in your environment. Let's test it with your workflow. But we're not proving what we've done, because we have already proven that with dozens or hundreds of customers already. We know the technology works, and we got to get that mindset past that. So.
Mm-hmm.
Yeah, and I guess Corey kind of stole my words, and hence I kind of jumped in. Sort of apologize, Mary. But just to add to that, I mean, all of us, I mean, most newer technology companies would have faced this. You go to a municipality and you say, we have a technology, we have a solution. The first question you get asked is, how many references do you have? Well, we have a dozen references. In Europe, it's like, how many references do you have in North America? It was like maybe 2. Okay, how many references do you have in the U.S.? one, and how many references do you have in the state? So it goes down to really that fine, and not trusting, or I should say, not giving a chance to a technology or a solution that has been not tried locally, like in your neighboring community or your neighboring city or neighboring municipality. I think that needs to change, and I believe it has changed over the last half a decade to a decade, but that needs to be still better. As you have seen, startups would take years before coming to stage where we are right now, or maybe where Corey's company is, or where John's company is. But then technology adaptation at that municipality levels needs to shorten as well. They need to be more receptive of newer technologies. So just to add to what Corey said, I would agree to that.
Yeah, well, I just have learned a lot from each of you, and I think to just reinforce what you all just said, technology is a horizontal play. Once it's proven in one place, it can typically be applied in, especially your technologies, could work across the globe with the water of the same, level of solids, or the pipes of the same, size or structure. And I think absolutely, let's get rid of pilot. Let's say, if you want to, what is the word we should use? Short term. We'll give you a chance to demo in your area the application to make sure it's a fit and to educate your team on it. And I think the one last thing that I see happening is adding the human element to training. Don't just assume the technology works, but I see the clock is ticking. And gentlemen, I just want to thank you so much for a great hour. We'll
Thanks,
see you
Mary.
in
Thanks,
Global
all.
Water and Blue Tech Week. Thank you. Okay.
Thank you. Take care.
Great.
Bye-bye.
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 Thanks, everyone.